Now, AWS support containerization. But first, what is a container? A container are a method of operating system virtualization that enables you to run an application and its dependencies in a resource isolated process. By using container, you can easily package an application code, configuration, dependencies into an easy to use building block that deliver the environmental consistency and operational efficiency and developer productivity and version control. So in AWS, we have multiple container services and they are supported Docker. But what is Docker? Docker is a software platform that packages software such as application into containers. Docker is installed on each server that will host the containers, and it provides simple commands that you can use to build, start, or stop a container. Docker is best suited as a solution when you want to standardize the environment, reduce conflict between languages, stack, and versions, and use containers as a service. You can run microservices using a standardized code deployment and require a portability for data processing. In AWS, there is multiple services that support containerization, and the first one is Amazon Elastic Container Services, as we are going to see in the next demo. It gives us the ability to manage our container, and you can launch one or more AWS EC2 instances, and you will install Docker engine in each instance. Then you will use the Amazon Elastic Container Service as a highly scalable, high performance container management service that supports Docker containers and enables you to easily run your application on a managed cluster of Amazon EC2 instances. In Amazon Elastic Container Service, we can launch up to tens of thousands of Docker containers in second, monitor their performance, and manage their state. And we can also schedule containers by using a built-in scheduler or a third-party scheduler, for example, like Apache, MissOS, or Blocks. There is also Amazon Kubernetes service, which support an open source Kubernetes software for container orchestration. Kubernetes can work with many containerization technology, including Docker. Because it is very popular in the industry and it is an open source project, a large community of developers are using Kubernetes. So Kubernetes enables us to build and deploy and manage the application at scale. For this reason, we have the AWS Kubernetes service. So you can look at your application as a set of containerization that you need to manage in the cluster. With Amazon Elastic Kubernetes service, you can manage those Kubernetes application and Docker containers as a cluster. Amazon Elastic Container Service automatically manages the availability and scalability of the cluster nodes that are responsible for starting and stopping containers. You can schedule containers on a virtual machine. You can also store cluster data and other tasks. The last thing is the Amazon Elastic Container Registry, which is very similar to Docker Hub. With Amazon Elastic Container Registry, it is a fully managed Docker container registry that makes it easy for you to store, manage, and deploy Docker container images. It is fully integrated with Amazon Elastic Container Service, where you can store, run, and manage those container images for your application, and you can specify the repository and the task definition that you want to use. In the next demo, we are going to explain each of those three components to support containerized application. So let us look to the Elastic Container Service. So when you go to the AWS and you look for Elastic Container Service, or you select it from the menu, this will take you to the Elastic Container Service. And we can see here we have Amazon Elastic Container Service, cluster, task definition, and this is where we can create Elastic Kubernetes Service. And this is the Amazon Elastic Container Registry Service, which is very similar to Docker Hub, which is a very popular container registry where you can put your images, and these images will be available for the community. Now, in Amazon Elastic Container Service, the first step is to create a task definition. So when you go to task definition and you click on create a new task, you have to select whether you are going to run it in a Farget, which is an AWS managed infrastructure and it is a serverless computing, or an Amazon managed Elastic Container Service EC2. So let us select for this demo Amazon EC2. And then we click on the next. So for task, let us call this first task. We don't have any role or any network mode that we need to worry about. All we need to do is to add a container. You have now two options. Whether you add a container from Docker Hub, like WordPress, this WordPress here, or you can basically add another service. Let's say in Docker Hub you want to run NGX. So let us now run NGX in container service. You know, if you are familiar with Docker, you can pull this image and you run it as a container in your machine. But in this case here, I'm just going to run it as a task in container services in AWS. So let me call this NGX, and you need to pass the image. Now the image in this case is going to be NGX, and this will be the latest. NGX is going to get me the latest image of NGX. You can specify hard limit, like for example 102 or 256 megabyte of memory. You can also do port mapping between the host port and the container port, like port 80. You can specify a health check. You can specify an environment variables, and furthermore, you can define the whole container using JSON format, which is the most common way when you want to configure, for example, a task in AWS. You better configure it as a JSON formatted task. So in this stage, we managed to create a task, and the next step, we need to have the family of the task. Now the task family, in this case, we are going to put this container, if you notice here, we are going to put this container in Elastic Container Service. So you could go back to the NGX and you specify what exactly you want to run in this task. So now I created my first task, and the next thing is I'm going to create now a cluster. To create a cluster in Amazon Elastic Container Service, you could go to the clusters and create a cluster. You could go also to the Get Started, which can give you a tutorial of how you can create a sample app or NGX, whether you want it to be in Elastic Container Service or Farget. Now, in my case, because I have already a task that I already defined, I want to click on Create a Cluster, and the option here, we could create a networking only, or we could create an EC2 Linux and networking, or EC2 and Windows. In our case, we are going to select EC2 Linux plus networking. Click next. I will call this my first cluster, and I want to run it on an on-demand or on a spot instance. I will keep it on demand. And from the instance type, I need to select the T2 Micro, because these are the free tier one. So T2 Micro is going to be more than enough. Number of instances here, I will select 1, and the size is going to be, the root EBS volume is 30 gigabyte. I don't need any SSH key. And in the VPC, I will keep this to the default, where Elastic Container Service will create a new virtual private cloud. And then in the container instance IAM, I could specify if I have a specific IAM I want to pass. Now click on Create, and this is need an IAM role, which is the lab role here, and I'm going to click on Create. So this is going to create the cluster, and will take a few minutes for creating and launching the Elastic Container Service and the EC2 instance. You could go back now to your services, or you open the Elastic Container Service in a new tab, and here you can see I have previously created a cluster, and this cluster is basically running on Farget. So I could basically run my same task, which is NGX, in this Farget cluster. So let me show you how to do that once I have my Elastic Container Service ready. So I'm going to run my first task. There is no revisioning, and all I need to do is just to run the task. I have to select the launch type, and this is going to be Linux. You could go to the first task itself and create from it a modification. So you can basically copy a new version of it, and you can make this Elastic Container Service to be running in Fargate and in Linux operating system. And don't forget to have passed the correct role. Now remember here, we are going to have version 2, which is the one we are going to run in Fargate, and version 1 we are going to run in, and I will specify the memory, the minimum CPU, and then here I need to specify the mapping of my port. And here I just need to expose port 80 because NGX is working at port 80. So now first task 3 is going to run in my Fargate cluster. So I'm going to go to the default in the task, and I will run as a new task. Make sure this is a 3, and I need number of tasks here 1. I could put here as long as I need, like as many as I need. This is going to be the default cluster, and then I will run the task. Launch type is Fargate, and run a task. This is Linux, and the cluster VPC is going to be this VPC and this subnet and this subnet, and the security group, I could edit the security group and I enable port 80, and then I run the task. So the task will be running now, and you will see after a while that this task is going to be run as a service in the Fargate. Now if you go back to cluster, leave this pending here, go back to the cluster and go to the first cluster. Now my cluster is ready. I could go now and run my Elastic Container Service, but this time I will put version 2, and this will be running a task. As you can see here, it is now running. So I could look to the task definition, and I will find that the NGX is running at this port. So if I open this port, I could see now this is welcome to NGX, and this is running from Elastic Container Service. If you go back to my default, which is the Fargate, you will find that my task is also running, but this time it is task version 3. If I select it, this will give me a public IP address, and this public IP address and it is give me a public IP address, and if I open this public address at port 80, I should be able to see NGX.